Welcome to the Futurisity Podcast. This is episode number 5 with Katja Sirazitdinova, data scientist for computer vision, video analytics, and deep learning at Nvidia. In today's episode, we'll be talking about computer vision, or in other words, how can we make AI systems understand the visual world as we humans do? So great to have you here, and thanks for finding some time for an episode. Why wouldn't you briefly introduce yourself? According to your CV, you've made a long way from Irkutsk in Russia to Munich in Germany. And I'm speaking not only about the distance, because it's roughly like 7.5 thousand kilometers actually, but also your journey from banking informatics to medical image processing, then to computer vision, and after all, to video analytics. How did this transition happen? What made you move from Siberia to Munich?
Hi, Vlad. First of all, thank you for having me today. I'm really glad to be here and talk to you. To your question, well, it's a long story, as you said. Back in the day when I was studying, we'll call it economical informatics or business computer science, I felt like I was kind of going into between two directions. First is economics and the second one is computer science. And I felt like development and computer science was something which was more interesting for me. Mm-hmm. And that motivated me to apply for, my master program, which I did in Germany in RWTH Aachen University. Mm-hmm. And it was medical informatics. So funnily enough, back in the day, I was more into web technologies, and I was actually seeing myself as a maybe like back-end or front-end engineer. And I picked this master program in media informatics basically because I thought that I will be learning web technologies and stuff. But then during my studies, I developed interest in computer vision, computer graphics. I did also game programming, and I've learned, I got more experience like in C++ programming. And then I felt that this is the direction I want to develop. And when I was doing when it was time to do my master thesis, I got invited to write a master thesis in the Institute of Medical Informatics. So that was mostly like how I ended up doing computer vision in healthcare.
Wasn't it difficult to understand because it's completely different domain knowledge as well? Like if you are landing somewhere in the healthcare, you have to deal with a lot of medical informations, maybe some, medicaments. I'm not pretty sure, maybe some diseases or whatever. So wasn't it difficult? Can you maybe explain a bit more about this?
That's absolutely correct. You need to have some domain knowledge, and of course I didn't. So the first project I was working on was melanoma classification, like it's a skin lesion, skin disease, and I actually had to go to the website like PubMed and learn about this disease and how it looks like. So this domain knowledge was really very important. And then after my master's, I decided to do my PhD at the same institute where I was writing my master thesis, and we actually had to take an exam in like anatomy and some diseases. So it was I think I never imagined myself doing, but
Yeah, that's what I was really excited about it, because I was looking on your LinkedIn profile, and for me it was like, whoa, like you've started somewhere in a business informatics, and then you've landed completely in a different sphere, like in a computer vision, in image processing, in a healthcare. So
it was very unexpected to me as well, but yeah, I mean, it's never too late to change, I think.
Okay. What makes you wake up every day in the morning?
Well, I guess it's life itself. First of all, I really like that. Having this opportunity to learn something new, be it professional or not, experiencing the world, meeting new people. These things keep me excited. And from professional point of view, I really value when I am able to be in help for others. And it's also what my current role, I work as a data scientist, and in my day-to-day job, I basically help our partners and customers solving different problems in video analytics. It's not only healthcare now, so So yeah, being of help to seeing how the customers or our partners, they are happy about me helping them. And that also motivates me. And finally, also, I like solving interesting challenges, and my job is quite challenging. So yeah, I think it's also a very fun thing.
Can you maybe briefly explain what is inside of your every day-to-day job as a data scientist for video analytics? I mean, can you maybe give some couple of examples of what customers want from you or from your team or from the department where you're working at?
So I am on the embedded team, which means I work closely with devices like Jetson, which is our tiny embedded device with a small GPU card in it. It's an ARM-based device with an integrated GPU, which you can use basically in small devices. For example, when we talk about inference on the edge, that you send your data to the server, but you can process it directly. And it's very useful for robotics applications, for video analytics, surveillance applications. And many customers, who develop for this hardware, they also, we also at Nvidia, we actually think we are not a hardware company, but we are a platform company. So we develop a lot of software, and everybody who is in data science or in computer vision or computer graphics knows about CUDA. So CUDA is, of course, our legacy, but we have also stepped up frameworks like DeepStream for video analytics, Triton Inference Server for inferencing. And my goal, my responsibility is actually to support the customers who want to integrate the software products in their final products. And so I have to be an expert in all these products. And also my main focus is inference optimization. So I help our customers to increase their throughput, to reduce their latency if they want it.
Talking about all your specifications as a data scientist, what is your approach to problem solving? I mean, what are the steps for finding some keys for a specific challenge? Basically, when you have some kind of a problem, which steps are you taking in order to solve this challenge?
Well, here I did not invent anything new. And I think my main approach is to decompose a bigger problem into a set of multiple smaller problems. So divide and conquer. And the second principle is never reinvent the wheel. For example, I face a new problem which I haven't heard of or I have no experience with. First thing I do, I just go on web and I search. Maybe there is already a solution for this problem. And it usually always helps.
If you could give one tip, maybe for all the listeners of this podcast about like the problem solving, what would it be? What is the most crucial part in order to maybe understand, to decompose,
So first of all, you need to have a clear understanding. What do you want to solve? What is your actually goal of?
Requirements are really important here.
Exactly. And the second, which I also take from my background, as my hobby, I also like to learn about human-computer interactions and designing interactive systems. And also a golden rule there is understand who your users are. So if you're developing a product, so if your problem is to develop a product, you need to know who are the users in order to develop it, have it like targeted to your specific user category.
Now let's move to computer vision. Talking about challenges, let's talk about one of the greatest unsolved problems in the AI world. And additionally, your domain you're working on, computer vision, supervised learning, convolutional neural networks, self-supervised learning. There are plenty of different technologies, tools, methodologies, and so on and so on. Can you briefly explain what computer vision is? So maybe, as you've said, deconstruct it to the fundamental principles and how does it work?
Well, first of all, computer vision is a very ambiguous term, as I see it. And in the traditional sense, people see computer vision as something which refers to 3D reconstruction, multiple view geometry, point cloud operations, SLAM, robotics, and so on. And this is something I actually worked on during my PhD, so I really had experience in this technologies. So here the principle is basically to see the world and to decompose the world from 2D to into 3D. And for that, you have various sensors, like be it a multiple camera system setup or be it some structured light sensor. So there are different things and different technologies. And the goals can be, of course, also very different. So it can be you want to reconstruct a sparse point cloud in order to just store a representation of the world. You may use this point cloud, for example, for things like navigation, like autonomous driving cars.
Yeah, autopilot, for example, yeah.
LiDAR technologies. So this is all what falls into this geometry category. But in a more broader sense, of course, computer vision also can include tasks like tracking, recognition, all sorts of image processing. It can be also done in 2D. And well, we can, of course, like in the recent years, we heavily rely on deep learning and AI. And we can have different tasks and different problem formulations in AI.
Okay. On this point, one question I'm really curious about. What is one use case of a computer vision that you've seen and said, whoa, insane? Because everyone knows, or at least like has this understanding of autopilot, for example, or image recognition, or I mean, object recognition. On the opposite side, what is one use case that you've seen maybe in your life or in your professional career?
Hard to say. I mean, it's probably, it comes with the experience that you think that, wow, this is something unimaginable, but then you have to deal with that on a daily basis, and then it stops being very surprising. So maybe back in the day,
it's not miracle anymore when you deal with it, probably.
Exactly. So it's really hard to get something on top of my head, but maybe like back in the day when I just started working in computer vision and learned about things like structure from motion. I found it really fascinating how just taking a set of some random images of one object, you can have a 3D model. And there was like a very inspiring paper back in the day, building Rome in a single day, when they queried multiple images from Flickr, multiple images of Rome, of the city of Rome, and they basically created a reconstruction of the city of Rome.
Really?
Just based on these queries, yes. So back in the day, that was something which I found really amazing.
I have no experience in computer vision because I'm just curious about technologies, and I'm learning about it. I'm trying to figure out who I am, and like on a professional scale. And that's why I'm pretty interested in such things as, for example, you said, Rome reconstruction. Like, I'll definitely check it out.
Yeah, it was pretty cool. It's already quite old, I would say, like from the year 2014 or even earlier. I'm not sure, back in the day, but yeah, that was such an eye-opener for me.
Why is computer vision hard to solve? If we are talking about some intelligent AI system that can see the world as we humans do.
Yeah, that's the main key is that machines are unable to see the world as humans do. And first of all, computers are not that good in recognizing patterns, and meaning that humans, as a human, we can work with context information, but a computer, it works with facts, factual information. So that's why it's like when a person, for example, when we see an occluded object, our brain can already have some connections, and seeing just a part of this object, we can say, okay, yeah, we see the clues, and we can tell that this is this particular object. But for a machine, if it hasn't learned about like partial representation of this object, it might be really hard. The second problem with machine vision is that the real world environment sometimes it has like patternless structures.
Mm-hmm.
And such patternless structures are really hard to interpret.
Mm-hmm.
And in addition to that, we can have like reflections, occlusions. So these are like big challenges for AI, and not only for AI, but also for like computer vision, as for example 3D reconstruction. Like also coming back to the topic of 3D reconstruction, the way how it works. For example, also back into this paper, like building Rome in a single day. The way it works, they recognize some interesting features in the images, which they try to match with, like they find like these features matched in another images, which is similar. And this process is called triangulation. But if we cannot find any interesting features, so it's if, for example, it's some smooth objects without corners, and by interesting features, there are like some very, very descriptive features. They call them feature descriptors, which are persistent in any angle, in any light conditions. So it's like, for example, angles in architecture, structures. But if we have some smooth objects without any patterns, it's really hard to find this match.
Okay. From my inexperienced perspective also, the biggest problem with it is that human vision, like as we humans see the world, happens to, I don't know, maybe 98 to 99% unconscious. And we understand, okay, this child is moving from point A to point B, and this person giving a bag from like the person to another person. Kind of complicated to transmit this unconscious understanding of the world to the machines. And correct me if I'm wrong, but I think if we look a bit deeper into the neuroscience or from the biology perspective, and we try to see the complexity, so it's getting then pretty clear that solving computer vision is also a big neuroscience and biology task. What do you think about this?
Well, absolutely. Also, our hardware, and I'm not talking only about Nvidia, but getting better and better every year. Still, it's not that advanced as our brain. And of course, that's still a way to go. If you, for example, want to achieve someday general AI, you know the term general AI. So if we want to achieve it, of course, it will take years and years from now.
But we are moving forward to it.
Of course.
What do you think? Is it a good thing or a bad thing? Like from the ethical perspective?
It's a tricky question, and I gave it a thought many times. And well, I tend to believe, and I hope it's a good thing. And it's our responsibility as like from the developer perspective to make sure that it's going into the right direction. But I mean, of course, many wrong things can happen.
I'm also curious about like when we're speaking about general AI, do you think there should be some kind of governmental regulations of AI?
Yeah, I believe it is necessary. But again, here is a question: if, for example, one government making use of it for like bad things, right? And well, this is actually what is happening now in Moscow, right?
Yeah.
They are using AI to detect people who are going to protest. And I already heard about a case when like some girl posted something on Twitter, and they used face recognition to find her and find where she lives. So this is already scary, right?
I've experienced it 2 years ago in 2020, in August 2020 in Belarus. I wasn't in Belarus, but all my friends and relatives were in there and are still in there. And we had this huge wave of protests after the elections. And and basically same story I see right now in the Moscow. So one-to-one, as you've said, government uses facial recognition, trying to get all these people who are going to the demonstrations. Really, we have so many people in the prisons right now as never before. I mean, it's unbelievable. And that's what unfortunately happening right now in Russia as well.
Yeah, this is so sad. And of course, as a developer, you don't want for AI to be used for that. But I think it's hard to control that.
I'm pretty convinced there should be some kind of international regulation of AI, of a general AI, and not on a country level or on a, I don't know, community level.
Yeah. Also, there are so many stories from China where
that's crazy.
So scary.
Those guys are really all right. So one more thing, what is more difficult, language or vision to solve?
This is this is hard to answer because I think each have their complexities and challenges. For language, a big challenge is that you need to process lots and lots of information, and also language is such a thing which also evolves all the time. You have to retrain your models like constantly on a daily basis. And I've talked to some guys who work on language processing. I work only on vision, but I know many people, of course, who work in language and or, for example, things like recommender systems. And I asked them, how often do you retrain your models? And they said, like, yeah, we update our models like on hourly or daily basis.
Really?
Crazy. Yeah. For recommender systems, it is like hourly basis, and for language, it's a little bit slower, but still, yeah. And you need a lot of like huge infrastructure, like a single GPU is not enough. You need a data center to train a big model. Like now, transformers are very popular for language processing. Like we have a model BERT, which has like so many parameters inside. Then it takes really long to train it.
Can imagine. Are you talking right now about like large scale models? So some kind of Netflix recommender systems?
Yeah, like for example, like I have customers who work, for example, in retail and have like retail websites which sell like apparel. So for the websites like that, it takes them 1 hour. They have to update the models on hourly basis.
Jesus.
Or for Netflix, I think for Netflix it should be the same.
What was the most difficult AI challenge that you have ever solved in your life? And how have you solved it?
Well, it's once it's solved, it doesn't seem difficult anymore, right?
Yeah, but I mean, back in the days when you were sitting on a problem and maybe you got some requirements or whatever, maybe it was at the university, but still, what was it? What were you working on?
Well, I can talk more in general. So my day-to-day challenge is to optimize inference, and sometimes it's rather challenging indeed. Like when a customer comes to me and says, "So here my model, which works like which has the throughput of 5 frames per second, but I need it to work real time." So this is a typical challenge I solve on a day-to-day basis, and I already have developed a set of techniques which I always apply and suggest to apply. So such techniques like pruning, quantization can be really useful.
Okay. Jitendra Malik, the professor at Berkeley University and one of the most influential people in the computer vision world, has mentioned in one of his research papers his 3 R's of computer vision: recognition, reconstruction, and reorganization. They should sound familiar to you. You've been already talking about the reconstruction. Can you describe like all the R's?
So first of all, it kind of feels that this 3 R's is already a little bit outdated and it's not that widely used, I would say.
Okay.
And when I've heard about it first, I actually had to Google what is reorganization.
Okay.
What does it mean by reorganization? And apparently, what he wrote in his paper is that, or is it he or she? I'm not sure actually. Yeah. So what he wrote in his paper is that it's kind of it's something what we call in deep learning segmentation.
Yeah. Okay.
how I understood it from his paper. Segmentation in deep learning, we can also have like two ways. It can be semantic segmentation, or in other words, scene understanding. It's when you take a 2D image, and let's say for like a popular use case is a cityscape. Like we have, there is a popular data set and a challenge in Kaggle. And you want to segment the scene, you have there like segment cars, to segment the road, to segment trees, a set of objects. There is also such a thing like instance segmentation, where you have also, let's say, a 2D image, and you are segmenting like some object or parts of this object, like a person, and you find the precise outline of this object. So this is how I understood what he means by reorganization. And by recognition, of course, well, this is what we in deep learning call classification, and it can be also detection. So in classification, it's basically you have a 2D image and you identify whether there is some property can be predicted for this image or not. So the most typical example, whether we see a picture of a cat or a dog. And when we talk about detection, it means we find the object in the image and draw a bounding box around this object. So like in the more like modern words, like I mean, reconstruction, it remains reconstruction. Recognition, it's a broad term again, which we can say classification, detection, they also fall into the category of recognition. And then finally, reorganization, it's segmentation. And I think what he referred in his paper was scene understanding, semantic segmentation.
Semantic segmentation. Can you explain to me maybe what is the difference between semantic segmentation?
That's what I mentioned already. Like, for example, in this, like the whole scene, you label like all objects, like, and you have multiple categories. And you say, here is a road, here is a tree, here is a
dog, car, building.
So basically, as an output of your deep learning prediction, you have a very colored image with multiple labels, and there are no blank spaces left, let's say it like that.
Another question was, what is the difference between object recognition and semantic segmentation? Because I still cannot get like the whole difference between those both terms.
So like when you talk about an object, you don't care about the background, right? So you have like this cat in the picture, and the only thing you're interested in is defining the coordinates of this cat. You're
looking for a cat, and you're trying to define the cat on a 2D image, for example.
Exactly. So you draw a bounding box around this cat, and this is like, you have localized your object in the scene. And this is also like the morphological segmentation. It's like one step up, because now you have like also the whole contour of the object there.
Getting clearer. What are the main differences from your perspective between video processing or video analytics and image processing? What are the key differences?
Basically, video processing is image processing, but I would say it's a step up in terms of design of your application. And of course, the tasks are a little bit different. In image processing, we usually work with static objects, while in video processing, we can still work with static objects, but we can also answer the questions like address the problems of object tracking, behavior recognition, what else? So the difference is, basically not the difference, but the key approach to solve a video processing task is to solve an image processing task first. So a typical example would be, let's say we want to predict an intention of a person who wants to, let's say, fight with another person. And let's say we have a surveillance camera, which detects one person moving towards another person. And first step, what we need to do is to first detect this person, track this person, like to find like what are the steps, and then maybe to apply also some further machine learning or deep learning techniques to analyze his or her behavior. Maybe he or she is moving in a like some weird way, which can indicate that this person is like angry or agitated. And then we can predict that maybe this person wants to fight.
Okay. What I was thinking about, I guess from my also inexperienced perspective, some kind of tasks are way more easier, way more easier, but easier to solve with a video rather than with a static image, as you've mentioned with the intentions, right? Do you think that I'll try to formulate the question. Do you think that in some cases for big companies, there is more sense to use in some cases video and track the videos and not get the static images of a scene?
Of course. Another popular use case is, for example, in football games, right? When you want to identify where the like statistics about like ball being on this part of the field or in this part of the field, or when we want to use it to like prove that like some situation happened there. Another interesting application also talking about football is that many teams who are not very popular, but they still want like to have recordings of the game. They use like the 360 cameras which can rotate or follow in the ball. So for that, you definitely need video analytics. So static is something which is just not, the problem is unsolvable with static image, right? So you need sequence of different frames. Also things like action recognition, where you want to identify which, some heavy object is falling. So it's also dynamic. So it's just a different problem formulation, I would say. And of course, video processing, as I mentioned already, adds another level of complexity. So because for many tasks of video analytics, it's really important to have real-time performance. And which means that basically to process video, you need first to decompose it in like a sequence of frames. So instead of processing a single frame, you need to process a number of frames, like 60 frames per second, 30 frames per second, and the task, of course. And that's a big challenge especially if you want to run it on the edge, like on a tiny GPU, because you know that the GPU is limited and you cannot process the whole thing. You can batch, but sometimes it's still not enough. And some deep learning architectures are also, still far from being real time.
So it's also a big infrastructure and hardware problem as well.
Of course, you need to be a good software engineer to avoid bottlenecks. So, for example, when we talk about CPU and GPU, the bottleneck is moving the data between CPU and the GPU. And if you can program your system so that the data is being passed as pointers within the GPU, it will be much more efficient than if you will move the data back and forth, right?
So basically, you have to be not only a data scientist and deal with the data, but also a good software engineer.
Exactly. Like it's really crucial to have good computer science and software engineering knowledges for that.
How would you start today? What are your recommendations for the beginners in the field? And what is maybe the perfect ratio between software engineering, between statistician, between data scientists, between analysts, between all these kind of major things that are really crucial for a job in a computer vision or in video analytics, for example? Maybe, some crucial subjects that everyone has to deal with before starting the journey.
Well, as a person who tried so many different things.
You're a perfect person for that.
Yeah, I guess my advice would be do whatever inspires you and makes you excited and happy about what you do. And you'll figure it out on the way. Maybe you don't want to be a computer vision engineer, right? So if computer vision is something which excites you, then you'll find a way to learn it without following any guidelines, and there's no guidebook. You can try. Of course, you need to be a good programmer. You need to have good skills, and for that, I would recommend solving like challenges as lead code, for example, or HackerRank. I do those sometimes, like just for fun, because I like puzzles.
Okay.
Then learning from public sources, like taking courses at Coursera, is also always helpful. There is a good deep learning course from NYU. It is also open and public, and I love the content, and they also share with you.
What's the name again?
Deep learning course by Jan LeCun from NYU. Really highly recommended, and it's quite new, so they update materials like every year, I would say, and they really touch the newest topics, and it also keeps you up to date with the things. Doing some challenges on Kaggle. If you don't have real problems to work on, just go to Kaggle, pick something which you find fun and interesting to work on, and do that. I believe practice is the key element of success, and I always prefer to learn by doing stuff. So if I want to learn a new technology, I go and find a challenge with this technology and try to solve it.
You are not the first person on this podcast who was telling that to get hands dirty with the projects and with the real world, some kind of challenges, it shouldn't be like a real game changer and, solve some real world problems, but work on the projects and do something with your own hands.
You know that, yeah, that's definitely an important thing to do. Gain real experience. Also on some toy problems, still helps a lot.
How important is it to read scientific papers in the everyday work of an AI engineer? And I'm talking about all possible domains: machine learning, deep learning, computer vision, language processing, whatever. How often do you read scientific papers? Maybe you have also some recommendations.
Well, it depends. If I don't have time, I don't read papers, but if I have time, I try to keep up to date because, AI especially is such a dynamically moving field, and there are new things being invented there, like on a weekly basis. And it's, first of all, it's important to keep up to date because, nobody wants to use outdated techniques.
Yeah, sure.
And if you want to be efficient, if you want to be good, you need to know the newest stuff. So for that, it's really helpful sometimes to follow like the major conferences, like my favorites one are CVPR, ICCV, or ECCV conference. NeurIPS is also an important conference in deep learning. So I usually, if I don't have a chance to go to this conference, one of these conferences, so sometimes I usually try to go at least once a year to attend a scientific conference and to pick, good papers to read or to learn more. But if I don't have time, I just look what they present there. And if I see that a paper is of interest to me, I read it. Sometimes I read papers if I want to understand a technology better. Like, for example, coming back to the topic of working on challenging problems is, when I Google for like some challenging problem, I usually find a paper, and this is usually the raw material, which gives you like the most information. Yeah, I can highly recommend the website Papers with Code, which has a good collection of state-of-the-art papers, and also sometimes there are links to GitHub projects, also super useful. But simple Googling is also always helpful.
I'm really curious right now because I came up with another question. How many programming languages do you know, like in Fluent, that you can apply?
Well, it's been like always different programming languages.
Because you were talking about so many technologies, so many things that you've tried in your life, and I'm really curious about.
So these days, I mostly work with C++ and Python. These are my two go-to languages, and I support my customers who work in these languages. But I do have experience with Objective-C for iPhone programming, with JavaScript from my web technology days, from like Java. I also had some experience with it. But these days, those are mostly C++ and Python.
Okay.
For computer vision and data scientist engineer, I always recommend these two languages. These are the key languages in the area.
That was my next question. All right. On our Futurisity podcast, we also have our special rubric named Blitz. And the idea behind is very simple. I'm going to ask you questions, and you have to answer them without any kind of deep reflection and pondering. Try to follow your heart and not your brain. So try to catch the first answer that came to your mind. Okay?
Okay.
Ready? Perfect. If you had an opportunity to have only one superpower, what would it be?
Oh, that's hard. Yeah, I'm a bit biased because we were talking about programming languages. Probably the superpower to write code without looking at any references.
Okay. Also a superpower. A highly recommendable, probably in a professional career. Huh?
Exactly.
What would be your one best single tip for all the data scientists of all the levels out there who are listening to this podcast?
For beginners or for
all the levels? If you could speak to literally all the data scientists out there.
Yeah, I guess reflecting back to what I said before, get your hands dirty. That's the way to learn things and practice. Yeah.
All right. One trip that you'll never forget, talking about the country or the city you've visited.
Well, my favorite country and the city is Japan, and the city is Tokyo. I did my internship there, and
oh, really?
I spent like in total almost 1 year there. I really love the country, and it's been not a single trip already, but that's definitely my favorite.
Okay, I've never been to Japan, but it's also on my to visit list.
Hopefully they will open soon. They've been closed due to pandemics, but
yeah, they had these Olympic Games as well, and it was also kind of horror. You're in Munich, right?
Yeah, I'm in Munich.
Right now, I don't know how it's in Munich is, but in Hamburg, where I'm sitting in, nobody is talking about Corona anymore. I mean, it's really lost topic.
Yeah.
Unfortunately, I mean, I would prefer to have Corona on a daily basis rather than what we have in Ukraine. Yes. Do you have any relatives or family members?
I only have far relatives there, but I have so many friends from Ukraine, especially here in Germany, and of course, I'm very worried for the relatives and families.
It's heartbreaking.
Yeah. But I'm also worried for the family in Russia, and
yeah, right now it's also unstable and crazy days.
Yeah, and the saddest thing that they are not realizing how bad it is.